Okay, for question 12, a series circuit had 6 volt source connected to a 1.2 times 10 to the power of 5 ohm. Okay, and then capacitor 60. So this one in series. Sometimes after closing the circuit switch, the current in the circuit was 15 microampere. Estimate at that time voltage across the resistor, voltage across capacitor, charge on capacitor, and energy. So basically they want to find VR, VC, and QC. Sorry, charge on the capacitor Q lah. And then energy of the capacitor is basically U. Okay, so I already draw the circuit over here to save some time. So this is the information given. I just redraw this one in series. Okay. So the first question, they want to find the voltage across the resistor. Okay, from the diagram that I draw over here, you can see that the current that is given is equals to 15 microampere. Okay, since there is no junction, all of this in series, so current on each component would be 15 microamp. So the same current pass through the resistor and the same current will pass through the capacitor. Okay, so if I want to calculate VR, I can use V equals to IR. This is from Ohm's law. But then if I use VR, I need to substitute IR and R. IR, I across the resistor, which is the same for the circuit. So VR is equals to 15 times 10 negative 6 multiplied with the 1.2 times 10 to the power of 5. And sorry. So this one, if you calculate, you should get 1.80 volt. Okay, and since this one is V terminal, okay, that means the VR is over here, because the next question want you to find the VC. VC is over there. So you can see from here that VR plus VC will be equals to V terminal, because this one is in series. So you can write down the V terminal equals to VR plus VC, because R and C is are in series. VC is equals to 6 minus 1.8, should get VC equals to 4.2 volt. Okay. Then the next question, they want to find the charge on the capacitor. So now you do have the VC, right? VC over here, you have capacitance. To find the Q will be straightforward lah. So you can use C equals to Q over V, where Q is equals to CV. Capacitance is 60 picofarad. Pico is 10 negative 12. Voltage just now is 4.2. The charge on the capacitor at this particular time would be 2.5 2 times 10 negative 10. Charge will be in coulomb. And then the last question D, they ask you to find the energy of the capacitor. So you can use U equals to half CV square, or you can use half QV, or the other formula. Doesn't matter, because you pretty much have all the information. So if you are using this formula, it will be 60 times 10 negative 12 multiplied with the 4.2. Don't forget to put square. Okay, this one. Oops. Times half. Here 5.29. And since this one is energy, it will be in joule. Okay, so there's actually one more question. I think I missed out the question. So the last question, I think I mixed up between question 11 and 12, but it doesn't matter. E, they ask you to find the maximum charge. Okay, so the maximum charge on the capacitor is basically when it is fully charged. So if you're going back to the diagram over here, at the end of the day, if this one is fully charged, then the potential across it would be equal to the terminal punya voltage. So if I want to calculate Q, which is C equals to Q over V, so Q equals to CV. So basically I have to substitute V terminal, C effective, but you only have one capacitor over here. So it will be 60 times 10 negative 12, and then you have to multiply with the voltage, the terminal voltage or the source voltage. So you got 360, so times 10 negative 10, 3.6. If you change the prefix, it will be 3.60 times 10 negative 10 coulomb. Okay, so next question is question number 13. They give you a graph in figure 2.4, show how the charge stored in a capacitor varies with time as it discharges through the resistor. Okay, and then the first question, they want to find the time constant, which is tau, and then capacitance, which is C. So the idea is that you want to find tau from the graph. You have to extrapolate the graph, and then you can find capacitance using tau equals to RC. Okay, first thing first, you have to find tau. So referring to this diagram, this one I just copied from previous lesson. So you can see that you can find the time constant when, this one is for discharging, discharging graph, discharging graph for Q against T. So you can find the time constant when the charge is actually at 0.37 out of Q0. So you have to find that position first. So I can write here tau when Q is equals to 0.37 Q0. This one from the definition of tau. So Q is equals to 0.37. The Q0 is actually over here, the maximum value, which is 6. So multiply with 6. Okay, be careful. Sometimes they put prefix over there, so you have to be careful. Here there's no prefix. Sometimes they put like micron or something. So 0.37 multiplied by 6, I got 2.22 coulomb. Okay, so I have to extrapolate from the graph 2.22. I think this graph can read one decimal point only, so it would be 2.2. So 2.2 would be, just zoom in a little bit. This one is 2, this one is 3. So each one of these 0.2, so 2.2 should be over there. We just extrapolate this one. Okay, maybe over there. And then if we bring it down, okay, I think it will be, this one is 15 and 10. So if you're not sure, you just 15 minus 10, and then you divide by the numbers of boxes over there. So I have 1, 2, how many boxes is there? 10. So each one of these is 0.5. So 0.5 times 4, 2 plus 10, I got 12. Okay, or you can label one by one. So here, tau, you can write from the graph. Tau is equals to 12 seconds. Okay, this one for question 1. For question 2, they want to find the capacitance, right? So since tau is equals to RC, time constant is equals to RC, so it will be 12 equals to 100 kilo multiplied with the capacitance. So C will be equals to 120 microfarad, or you can leave it in prefix. You get 12, you will get 1.2 times 10 negative 4 farad. It's the same values. Okay. Question B, I think you can do it yourself. You still have to extrapolate and so on.